Hello. Okay, so today is going to be a bit weird, very personal in a way. We're going to go from the dawn of time. You know, the talk that starts with long time ago. Galaxy far away. I started my career as a developer, right? Many of us started like that, right? You write code, that's what you do. You know COBOL, you know Python, you know Java, whatever you're doing, you write the code. And now I'm very old. I'm talking about 30 years ago, something like that, right? So all I knew how to do was write code, and then everything else that needed to be done was done always by somebody else. So realistically, I spent most of my time in those early days waiting for something to happen, right? Waiting for somebody to do something that will somehow enable me to continue writing code. And I was supposed to do stuff myself, like run manual tests, you know, look at something and see whether it's working, build some stuff and things like that, but that was at that time very unacceptable for me because it's kind of really, who wants to do the same thing over and over and over and over again?
Who wants to work?
Who wants to work? Yeah. That's why we joined this industry, right?
That's it, yeah. So
that's why we are speaking at conferences, so we don't work. Yeah.
We are lazy people, let's say.
Yeah. And Mauricio started the same thing, right?
I did similar path. Like I started as a Java developer. I started working a lot with like the financial industry and the healthcare industry, doing consulting, helping teams to build and deploy applications, but always using like a very strong developer perspective. I really cared about the applications that we were building more than how they were running in production. Right?
Yeah, that eventually, at least in my case, led me to do a bit less coding. I mean, when I say coding, I mean coding of end user applications, and figure out how can I not do my job. And by not doing my job is that I entered into automated testing, right? I started applying test-driven development, behavior-driven development. I started writing a ton of scripts that would do the things that I needed to do, right? And the reason why I'm saying scripts intentionally, because I'm talking 30 years ago, there was none of the tools that you use today. Kind of like none of those existed, right? So it was scripts that would do stuff so that I can watch television while instead of doing my job, right? That was the main motivation behind that. And that eventually led to other people starting using what I'm doing because they were lazy as well, right? And then the question comes along, if you create a bunch of tools, no matter what technology you're using, and those tools happen to be used internally by everybody else or many people in your organization, would you consider that a platform, right? Is that the definition of an internal developer platform? Tools that you built and other people are using to not do the stuff that they would normally have to do, right?
In my background with Java, right? So, next slide, please.
Next slide.
There
you go.
So in my background with Java, basically, I was working with application servers. How many people know what an application server is? Okay, so we have some folks. Yeah, there you go. So you actually are showing your age by raising your hand. So in Java, we had application servers. We started again, like trying to be more smart, like smart developers, using the application server capabilities to not rewrite functionality that was provided out of the box inside of our applications. At that time, I remember thinking a lot about like what libraries can I build so other teams can use to reuse functionality across the applications. In that case, I think that when I think it as like in the terms that we're using today, the application server was my platform because I was like relying on some application server capabilities to build my applications and to reduce like the amount of code that we need to write.
Yeah.
You were using a different thing back then, right?
Yeah. So let's say some 15, maybe 10 years ago, something happened that never happened before. And that something that happened was that we got a tool that you could use to define anything that should have been done in your organization. Whatever you needed to be done, you could do it with a tool. You need to deploy something, you can do it. You need to test, you can do it. You need to, build something. You could do any type of operation that today we do with platforms typically with that tool. And it got the API through which you could interact with that tool. It got the user interface with pretty colors, so that people who had terminals could go there and accomplish something, filling some fields and stuff. Any idea which tool it is 15, 20 years ago? What? No, wrong. Absolutely wrong. It's not Jenkins. It's Hudson. First it was Hudson, exactly. Then we got Jenkins. But Jenkins, if you think about it, if you think of the principles, but not the specifics that we consider today, Jenkins was the first internal developer, or one of the first tools we got to build internal developer platforms. Now, if you're using it today, you're insane. Just to be clear. Don't do it. If you did it 20 years ago, 10 years ago, you were doing great. You were doing great. And then, later on, something else happened, right? We got Docker. And Docker changed, again, that was a next huge shift in what we do, right? Docker was never related really with building platforms and things like that. It was more related to how can we package our applications in some kind of standard way and then run them anywhere except production. Kind of that was the definition of what Jenkins was doing. And it was great. I mean, it was the very beginning of something amazing. But what made sorry, did you say Jenkins? Docker. What made Docker really, really special is that it is the first time that I saw that actually engineers from different areas all got interested in the same thing, right? Because before, oh, I care about databases, I care about Java, I care about this and that. This is the first time that everybody said, oh, this is cool. We all want to use this. We did not know what to use it for at that time, kind of it was unknown, but it was very, very cool. But we still had quite a few problems with Docker alone, right? Because it was a great packaging mechanism, it was a great runtime, but we still couldn't apply it to production, right? Nobody could, unless you're having a copy. So if you're using WordPress, you can do it. Anybody else, you couldn't, right? And then we got Mesos. We got, actually not then, we actually got Mesos before Docker even, but let's say then. We got HashiCorp Nomad, we got Docker Swarm, we got Tupperware. Anybody familiar with Tupperware?
Tupperware.
Oh, you're old.
There you go.
Cool. And Kubernetes, right? And Kubernetes changed everything. And it changed everything for not such obvious reasons, right? Because most of the people, when you say Kubernetes, they think, oh, I can run containers in more than one server, right? That's what Kubernetes is for. But it changed everything because we finally, first time in the history, got into an agreement on something. We all agreed that this is where we're going to put our stuff, whatever our stuff is. Databases, applications, infrastructure, whatever it is, right? We finally got industry-wide agreement of where are we going to build stuff on.
And it was pretty interesting, again, coming from the Java background, working with like middleware in Java, in this case JBoss, I was working at Red Hat. For me, the story was a little bit different, right? So I was using application servers. I was working at Red Hat when they created OpenShift, the first version based on Kubernetes. And I started thinking, well, if we all want to use containers and run our applications inside containers, inside Kubernetes, how are we going to transition from application servers to this new world? It was like clearly to me back in 2015 that was the path forward, just to make the ecosystem multi-language, multi-application, multi-technology stack. And that transition has took kind of like almost like 10 years. Now Java developers feel more comfortable running applications on Kubernetes, but there has been kind of like all this journey in realizing that this is kind of like our new platform-based layer, right?
All that was happening a long time ago, right? I'm talking anything between 30 years ago and
15 years ago, 10 years ago.
Or 7 years ago, let's say, right? So that's the past, right? That's where we lived in the past. And if there is anything you should understand from everything we said so far is that when you hear kind of platform engineering, it's a new term. The term was coined maybe a few years ago, right? It's nothing new. We've been building, companies have been building platforms and failing to build platforms for 30 or 40 years now, right? We're not doing anything new in terms of what we want to accomplish. The technology and some patterns, that's what's new, right? That's what changed recently. So, we've been building platforms forever, and that brings me to the present, right? And the present is probably the most important thing you should get away from when you think about platforms, and in this context I mean internal developer platforms, the most important thing you should think about is that we know the pattern, right? There is no need to reinvent the wheel. We know, I'm not now talking about technology, we know the pattern that works. And the reason why we know what works is because it's been done many times before. And it's been done by AWS, it's been done by Azure, it's been done by Google Cloud, by Datadog, by Linode, by Hetzner, but whomever you want. Any single service in the world that is worth using today uses that exactly the same pattern for the public platform. All we have to do, no, not all, the first step we need to do when working on internal developer platform is to apply that pattern. It's always the same. And the pattern is as follows, right? You have service owners. Somebody in AWS, I'm using it as an example, owns EC2 as a service, right? They own it, they develop it, they manage it. You have service consumers, right? Those are all the users of that service that are somehow consuming it and doing something with it. And you create services. That service owner or service owners create and manage services. Consumers consume services. And services like monitors don't work always.
Touch the screen, yeah, there you go.
There we go. Okay, and every single service is consumed through the same mechanism. And that mechanism is HTTP API, right? When you use AWS, how do you use it? And if you say Terraform, it's not Terraform. It's Terraform goes to API, right? Whatever Ansible goes to API. It's always the API that sits between consumers and the owners of those services. There are always controllers. We might call them differently, but there are some processes, some applications in that something that is listening to that API and figuring out what to do. When you ask, I want a GKE cluster, there is a controller that does something for you, right? After you submit it to the API. What changed from that general pattern, this is pattern applied by absolutely everybody worth talking about in the industry. The only thing that changed is that for us mortals that did not start building something like AWS 20 years ago, the base on top of which we're building it is Kubernetes, right? There is no doubt. We can talk whether you should do this, whether you should do that, but nobody discusses anymore whether it should be Mesos or Kubernetes. If you're still in Mesos, go somewhere else. Not the talk for you, right? And the only really, the second step you need to figure out is what are going to be those controllers, right? Are you going to build them yourself? Or are you going to use third-party controllers? And most of us ended up with both, but started with third-party controllers, right? Including those, when I say third-party controllers, this is this, right?
All of them.
And by the way, every second you see this picture, it's worth 1 hour with the psychologist.
Yeah.
Right?
So just leave
Nobody
it 2 more
understands
seconds.
what's going on there.
2 more seconds off. There you go. Yeah, so, and I think that like when you look at all the controllers that we have in there, it's important to realize that there are a bunch of functionalities that you will need on top of Kubernetes in order to actually run your workloads. That's why I switched in the past, like in 2022 or something, 2018 or something, just to work on Knative, because scaling, you know, and serverless is it's kind of like a core set of capabilities that you will need. There are a bunch of other things like observability, security. No matter what kind of platform are you building, you will need this kind of behavior. So in my career path, I decided, okay, now I was helping developers to build like their applications where like the libraries that they needed to do so. But then I said, okay, maybe there are some topics that we need to push closer to the infrastructure, right? In this case, like the scaling aspect of it. So I said, okay, let's work on Knative. While you switch to something different coming from that developer background, right?
Yeah, that in my case, it was Argo CD and Argo other projects. But the point is still that for most of us at that time, we were choosing which third party we're going to use or contribute to, right? Yeah. We did not yet had, and I'm talking like 5 years ago, 6, very clear that there is anything beyond that. Right?
Yeah, I would say that like that's why we're talking about the presence. In the last like 5 years, we have been looking into this kind of like core set of capabilities that every platform will need, and I think that now we are moving towards the next phase, where we start thinking about how do you make your platform your own? How do you make it like domain specific? How do you make it easy to be consumable by your teams that have very, very specific needs? And that's why in 2022, I switched to work on the Dapper project. That basically, again, provides like a nice separation between infrastructure and complexity, and it provides APIs for developers to build their applications. As a developer, I think that I went from working on infrastructure, closer to infrastructure with Knative, going back to help developers and platform engineers to have the right mechanisms to build distributed applications that are quite complex nowadays.
Yeah, in my case, it was similar, different tool, but same goals, kind of. In my case, it was Crossplane, which also tried to do this conceptually the same thing. How can you make it your own, right? How can you make it not do whatever somebody else decided it should do, but how can you make your own APIs, your own controllers, and all that stuff? And I'm using, this is now personal, in my case it's Crossplane. You have other tools.
Yep.
The tools are not important in this story, just accepting the reality, and that reality is that whatever you're building, your platform is always going to be on top of Kubernetes, and that you will be using some third-party tools, and that you will be building your own APIs. If you're not doing that today, you will, sooner or later. That is going to happen, right?
Yeah, because again, at the end of the day, like platforms will be consumed by companies and organizations and teams. So we are not building AWS or Google, that it's generic set of APIs. Now you need your specific APIs to solve very concrete problems.
Go for it.
That's yours.
It's my slide. Okay.
That's your slide.
I
I don't even know what that is.
Basically, and once you once you figure out how to do all those things, you just continue the same path as other cloud providers are doing, right? And after you build your APIs, after you build your controllers, you'll be switching. And still, I'm talking what's happening today. You'll be figuring out how can we make it more user-friendly than people are using CURL, right? Or vget or wget or whatever people are using. And that's building dashboards, applying GitOps, doing observability, and so on and so forth. But those things, all those things come later, right? The first step always, controllers, service does something, API, how do we talk to that something, and then make it pretty, right? Phase number 3. And another important thing to note is, and I feel that many people still don't understand what Kubernetes is. Kubernetes is not a thingy that runs your containers and nothing else, right? We're using Kubernetes today to manage whichever types of resources you're managing. When you create a PVC, what do you get? Guess what? Infrastructure, storage, right? Ingress manages load balancers and so on and so forth. But now that's before, right? Now we're moving forward towards accepting a platform being built on top of Kubernetes and managing resources in other Kubernetes clusters or in cloud. Anybody on-prem here?
VMs, maybe? Yeah.
Okay, yeah, do SSH.
SSH.
Anyways, and we call that control plane, right? We're still not sure how it's really going to be called, but it's a control plane. That's a thingy. That's your platform that is managing resources wherever they are running. And then we got to the blueprints, right?
Yeah.
Because apart from figuring out, this is a very high level, right? None of those things mentions any implementation, how you do it. And then we move forward, maybe 3-4 years ago. Okay, how do we figure out actually give people better instructions, right?
Yeah, definitely. So I think that it was really important for me. I started writing the book Platform Engineering on Kubernetes in 2020. That was very early on. It took me kind of like 3 years to publish it. And it got published in 2023. So in the last 2 years, what I have been seeing is that consolidation happening in the industry, right? Like the book, it's all about how do you pick up these 15 different Kubernetes projects, how do you put them together, hide the complexity behind platform APIs, and provide services to users. But again, it's like very domain-specific services. And the book, basically, for me, it has been a pleasure to talk with all the community here in the platform engineering space, because we can see more and more of these public blueprints being published by different companies and different open source communities. So this is the backstack. It uses Backstage, Crossplane, Kyverno, and Argo CD to show how to build like a very simple but very useful platform that you can start using it without thinking about how do you combine Crossplane with Argo and Kyverno and Backstage, right? I think that this is a huge step showing that the community is moving forward. We have these blueprints now, and we are trying to reduce the time that it takes to organizations to get started. The same with Kanui. Again, a different blueprint, a different combination of tools that you can swap components out depending on what do you want to use. But again, showing us the way on how to get there without figuring out all the combination of possible tools that you can use. And the last one, Fusion Stack, I think that's coming from China, but you can see this is a very, very complex platform bringing a lot of super interesting stuff around AI, monitoring multiple clusters. And we need to go faster, so...
Yeah, faster. Go. Continue.
Yes, so we have been doing this. Yeah, go.
The point is that kind of, this brings us to today, right?
Yes.
We figured out the patterns.
Yeah.
It's APIs, controllers, blah, blah, blah. We are doing the same thing as AWS is doing and other cloud providers, but on top of Kubernetes.
There you go.
3 minutes.
With that, let's jump to talk about the future. Let's do it as fast as I can. So extremely excited. There are certification coming in the platform engineering space from the CNCF. If you don't know about this, check it out. I'm super hyped because this means that as an industry, we are moving forward. This basically means that we can share knowledge about how to build platforms and the core concepts that we need to follow. The platform engineering certification, that's the most practical one. It will show how you use a bunch of different tools to build platforms, and that's pretty much, amazing, in my opinion. But there is still a question, because now that we have a lot of adoption on the top of Kubernetes and we are building a lot of Kubernetes-based platforms, do we need to hide Kubernetes from developers in the same way that AWS, GCP, and Azure are hiding away how they manage all the infrastructure? Do we need to actually hide Kubernetes from developers? And the answer is, as always, it depends.
No, it doesn't.
We can argue about that, but you can see the software starts in a developer laptop. It moves through the platform services and APIs and the pipelines, and it gets on top of production. So how do we at least hide the complexity of Kubernetes from developers? And there are different ways to do so. But I'm a true believer that the community is the best way to achieve that. That's why we are working with CNCF to create different groups that basically bring developers closer to platform engineers. There is no way that platform engineers can build amazing platform for development teams if they do not talk to developers and understand their needs. So we are doing a lot of work on that space. This year, for the first time tomorrow, we will have the application development track at KubeCon. This is a huge accomplishment on that front. We are bringing developer closer. We have very specific content for them to learn about what we are doing on the platform engineering side and make sure that we get their feedback to build better platforms. There is also some changes in CNCF. I will leave this for later, but you need to know that there is some developer experience work happening right now and groups about that. On the Kubernetes side, on the technical side of things, we've seen this happening in the last year or so, much more robust tools to do multi-cluster management and solve very specialized problems that we will face. If you haven't seen about Q, you should take a look at it. Q allows you to schedule batch jobs across multiple clusters in a very efficient way. If you want to do that manually or if you want to build your own controllers to do this, it's really, really hard. So check it out. It's called Q. You just definitely need to check it out because that's pretty important. KCP has a project that it was started some time ago. It's a very complex problem that they are trying to solve, which is accessing multiple clusters and managing multiple workloads and resources across multiple clouds, being kind of like that control plane that it's not just Kubernetes, but it's just a set of APIs. And I think that, again, when you are managing 200 clusters, you need these kind of tools. So you need to check that out as well. And finally, Carport, the one that I mentioned before, it brings kind of like that, multi-cluster observability and discoverability of resources using AI tooling and using real-time analytics. You should check that out if you're using multi-clusters nowadays. That's an amazing tool that I'm really looking forward to see. I cannot leave this stage without mentioning AI because, of course, we're in the AI world. And I think that we should use, as platform engineers, AI to prove our platform strategies. How do we bring AI functionality inside of our platforms without just calling an LLM from our applications? Because if we do that, then we are just wasting away all the platform stuff, all the standardization that we are bringing there. I wanted to show this slide not because it's part of the project that I'm working on. That's the Dapper conversation APIs that basically abstracts away how do you access LLMs, but because of that box down there. So if you want to access LLMs, you need to make sure as a platform engineering that your security is integrated with all the other security policies that you have in your company, that you can govern this access in a consistent way, that you have resiliency and observability there as well. And I'm showing this, but I'm also showing the Envoy AI Gateway, which pretty much does something similar. And again, this kind of shows that there is a need for making sure that when we adopt new technology, we do it just following the platform engineering practices. We need to cover all these cross-cutting concerns in a consistent way. Of course, you will hear this week a lot about agentic frameworks as part of the Dapper project. We also have an announcement about that, mostly because we want to share that no matter what kind of agent are you building, no matter the language that you're using, you always need some building blocks, right? Like you need persistence, LLMs, workflows, integration, governance. Again, we need to make sure that if we adopt any agentic framework in our platforms, or if we provide any agentic framework to our developers, that's being covered with all the governance and all the cross-cutting concerns that we need to cover, security, resiliencies, and stuff. So if you check Dapper Agents framework, you will hear a lot about this week. And there are other agentic frameworks out there, and I'm pretty excited to see how do we all work together to get this stuff running in production. Because I think that's the most important part. We can play with these tools, but how do we get this in production running? How do we make this secure and resilient? That's kind of like the question that I want to see answered this week, probably.
Yes, and you're out of time.
Out of time. So,
do we have time for questions?
Before we close, I want to say that. Come on, this is extremely important for me. Again, we are in a community event. Cloud-native platforms are not built in isolation. So if you are building a platform inside your company, make sure that you talk to other companies, make sure that you share your knowledge, because we need to push the industry forward. We need to make sure that all these tools that we have been mentioning are being used in conjunction, and we mature them all together. Again, talk to each other, be nice, and have a nice KubeCon, right?
Yeah.